So on question 5, you're asked to solve um, 4 equations. And I want to kind of stress this, that at this point in your mathematical career, solving should look like, I'll tell you what it should not look like. It should not look like guessing an answer and then checking that that answer works, right? At this point, we need to learn algebraic techniques so that we can solve um, and those techniques will continue to play out, and there's going to be something that we can rely on as we move forward in mathematics. So when I look at this problem, the first technique in part A that I use is this idea that if I have equal things and I add the same thing to both sides of this equal statement, I get a new equation that is equivalent to the original. So that's why I can magically just say, oh, look, I'm adding 8 to each side, right? These things I'm told are equal, and if you add 8 to both sides of equal things, you get equal things, right? And you can always see the truth of that if you look at something like this. Hey, 2 is 2. If I add 8 to each side, I get 10. Oh, guess what? 10 is 10, right? So if you have equal things and you add equal things to each side, you get equal things. And we call that the addition property of equality. So when I write this, the left-hand side becomes 2x, and the right-hand side becomes the number 28. And the division property of equality assures us that if we're dividing both sides by the same value, provided it's not 0, we get equal things. Think about this. If I tell you that, oh, you have 30 is 30, and if I divide both sides of this by the number 2, right, we will get 15 equals 15. If you have equal things and you divide by equal things, you get equal things. So this is the division property of equality. So now I'm dividing both sides by 2, and I get that x has to equal the number 14. A nice thing to do at this point is, and it's fine if you use a calculator, is to just plug that number in and verify that it does indeed make both of these sides the same. So 2 times 14 is 28, and 28 minus 8 gives me 20 over here, and I have 20 over here. So I like to do that. You'll often see me write this up above, and it's just a way of me visually checking to ensure that, yeah, this does exactly what I claim it does. It's making both the left and the right hand side equal to each other. So for 5a, the answer is 14. X is 14. Let's move on to B. On B, there's a application of the distributive property, right? I can distribute this negative 6 across the subtraction problem that lives in the parentheses. So I'm going to rewrite this as x plus 26, and that equals a negative 6x, and then plus the number 12. Negative 6x, and then plus 12. So notice I'm multiplying in the first case a negative 6 times an x, and then I'm multiplying that negative 6 times the negative 2, and that's where I'm getting this positive 12. Okay, so I guess next the thing that I'll do, is put that x back there. The next thing that I'm going to do is, let's see, I guess I'm gonna add 6 to each side. So if I add 6 to this side, I get the number 72. I'm sorry, if I add 6 to each, 6 times x, hello, I just woke up, thank you. 6 times x, on this side I have 7x plus 26, and over here that equals the number 12. And what I'm going to do now to each side is I'm going to subtract 26. And when I take away the same thing from both sides, I do get a new equation that's also true. 7x plus 26 minus 26 is 7 times x. And over here, 12 minus 26 is exactly negative 14. And when I divide both sides by 7, I do get that x must equal negative 2. So for part B, x was negative 2. For C, it's a little soon for this problem, but I think we can handle this, right? What I like to do is use this technique that we'll talk about quite a bit, calling it fraction busters. But what I'm going to do is multiply both sides of this equation by the number 8. And if you look at the reasoning, and this side also has to be multiplied by the 8. This C is a little close. Let me scratch that out. The reasoning for this is if I look at the right hand side, this becomes a 3 times x times an 8 over 8 times 1, which is just 8. I end up getting this giant 1. So when I multiply both sides by 8, on the right hand side my fraction goes away and I'm left with just 3x. And over on the left hand side I have 8 times 30, which is 240, right? So this new equation has no fractions at all. So that's the idea of this technique, fraction busters. Now if I divide both sides by 3, 240 divided by 3 is 80. So x is 80, and you can verify that 3 times 80 is 240. 240 divided by 8 takes me back to the 30. So x is 80. And then for the final equation, just a quick application of the distributive property, 2x plus 1 plus 4 times x, and then minus 8. So a couple errors I would see is that I would see this either become just negative 2, and that was probably the main mistake, just not distributing this 4 to both the x and to the negative 2, but just distributing it only to the x. On the other side we have 11. If I combine my like terms, 2x and 4x is 6 of them, 6 plus 6 times x. And then a positive 1 and a negative 8 is negative 7, and that equals 11. So I'm going to add 7 to each side, so that 6x equals 18. And then finally when I divide by each side by 6, we see that x is 3.